ゲストスピーカーの一人のオードリー・ターンから Perl 6 Today という、トークです。はい、お願いします。
Does this work? Okay, it works. Greetings, I'm Audrey Tang. I have this talk that is supposedly less than 45 minutes left. I have 200 slides. It's actually 2 talks. So the first one is Pugs and the second one is Perl 6, and let's see if I can do this. Okay, so Pugs is an implementation of Perl 6. I'm going to talk about it. I'm Audrey Tang. And I'm glad to have such illustrious translators as Takasako and Dan, who added a lot of words that I don't understand to my slides. I actually don't understand what it means. And Dan tried to explain. I can't just see what it means. So, but we can see what Pugs means. The definition of Pugs is a Perl 6 compiler. It compiles Perl 6 into something that it itself can run, or other people can run. And it's also a test suite that defines how Perl 6 should behave. It started out in Haskell, and then a lot of people joined in with a lot of languages, and then we start gradually to build more and more parts of it in Perl 6, until, of course, all of it will be in Perl 6. And some highlights. It contains the project. A lot of Perl 6 code is actually in use, some in production use. Oh my gosh. And there's more than 130 modules. There's a lot of examples in the examples directory, and there's a lot of unit tests that defines how Perl 6 should behave. For a very, very long time, people keep asking me whether Pugs will be, or how is it different from the official Perl 6. And we now have an official answer that Perl 6 is not defined by some accidental history. It's actually defined by the test suite, which conveniently is the Pugs test suite. And so just like Java test, the compatibility kit, anything that passes those test suite is Perl 6. Now, our test and the spec is very much tightly integrated. If you go into spec.pugs.org, you'll see this thing, which is the specification of Perl 6. And each paragraph is annotated with one or more tests in the Pugs test suite. So you can see that this paragraph is covered by this test and how it's passing or not passing. And when you're clicking on it, it will expand into the actual tests. And so you can see how they actually correspond to the paragraph that is defining Perl 6. Of course, it goes the other way too. If you go to smoke.pugscode.org, you can cross-reference the test against the spec. Embedding. When Perl 5 was first released in 1995, there was no CPAN. There was no really Perl 5 modules. So we have to start our Perl 5 scripts with those required lines, which requires those standard libraries from Perl 4. And in actual fact, they are still shipped with part of Perl 5.10 and 5.8. So we have this very fast CWD and very new GetOpt, not really, anymore. But those things are good because they let you continue using your Perl 4 scripts in Perl 5 without breaking all your code, and you can gradually start writing more and more new code in Perl 5. And that's, of course, a very good idea. So the very first thing Pugs did was to support using of Perl 5 modules, and by now it's actually quite seamless. You can use DBI, encode importing functions, template toolkits, and that's very convenient because we don't have to re-implement crypt. Our core implementation of crypt is actually just calling out to Perl 5, and it's very, very simple. So in actual fact, Pugs, by default, is a hybrid run core. We let Perl 5 handle the parts that it does really good at, like text processing, regular expressions, and Unicode. And we let Haskell do the parts that it runs very good at, like multiprocessing and all the numeric code. So you can use natively any Perl 5 module in developing Pugs, or Haskell module, or C modules. But in addition of going in, we also go out. We have this Pugs intermediate language, and with a very traditional compilation flow with only one exception. This part is not really traditional. But the rest of the flow is rather traditional. We parse the source into a syntax tree. We analyze it into intermediate code. We either run the intermediate code or fit it into the code generator and generate some JavaScript code or some Perl 5 code or something. Now, the non-traditional part here is that the grammar is not hard-coded as part of the compiler. Larry and the rest of the team is working on this Perl 6 std.pm, which is the definition of Perl 6 official grammar in Perl 6 itself. So whenever you make a change to this grammar in Perl 6 itself, it actually bootstraps and can parse Perl 6 into Perl 6 with Perl 6 And that's one of the critical pieces in the bootstrapping puzzle. And so with this intermediate code, we can, of course, in addition to targeting Haskell, we can also compile Perl to JavaScript, which runs in your browser, or compile it to pure Perl 5 so you don't have to install Haskell on your machines, and you can still use those CPAN modules. And of course, we can also potentially target other runtime systems. Now, I'll talk a little bit about this pure Perl 5 backend module because a lot of our team wants to use Perl 6 in their production, but there's a lot of strict regulations in many data centers that Perl 5 is currently deployed on, and the boss says it's not okay to install GHC there, or it's not okay to install some foreign virtual machine there. So what we did was we figured out the ways that we want to extend the Perl 5 virtual machine so that it can also very quickly support Perl 6 primitives without too much speed loss. And many of those work has already went into Perl 5.10, well, 5.9, soon to be 5.10. And more work will continue on it during the 5.11 development branch. And so the idea is, of course, when you have some Perl 6 code, it compiles to pure Perl 5, you can upload it to CPAN. When somebody downloads it from CPAN and install it, they don't have to have a Pux or a compiler or Haskell for it to work. And the flagship product of this extended runtime, there's many more, but Moose is by far the most stable. It's been around for 1 year. It's an implementation of the Perl 6 object orientation model in Perl 5, so you don't have to worry about all those, poo stuff in Perl 5 anymore. You can use actually a sensible object-oriented model. And actually just today, Stephen, the project lead for Moose, says Moose is turning 1 year old soon, and he's happy to announce that Moose is pretty much ready for general use. That is not scary anymore. So feel free to use Moose in your production code and use some bits of Perl 6 in existing Perl 5 code. And in addition to the pure Perl 5 backend, we also have this JavaScript backend, which is not unlike the Google Web Toolkit, or some people compile Scheme or other languages to JavaScript. And in the previous release, it passes about 90% of our unit tests really slowly, because Perl 6 has very advanced control flow features that JavaScript 1 just cannot support because it has no go-to. And so, we have provided feedback to Brendan and the other people at the Mozilla Foundation so that the next JavaScript language that's part of Mozilla Firefox 3, that is Xamarin, that is also ActionScript something from Adobe, will support this very quickly and natively, and that's the thing that we're targeting next year, probably. So we believe in agile programming, so we're delivering milestones. This has happened long ago, and currently Pux is a functional language that does things like closures and currying and all sorts of interesting that functional languages do. We're almost this close to finish this milestone. As soon as I have like 48 hours to myself, I can make a release, and it will happen probably in this week's hackathon, because we've already pretty much figured out how the object orientation stuff should go. So most of the development nowadays by Larry and other people are focusing on finishing up the bootstrapping grammar, so we can specify the Perl 6 syntax using Perl 6 grammar, that is the rule syntax itself. And after that, we plan to work with some Haskell people to figure out the type system of Perl 6 so we can compile Perl 6 into some really efficient code and robust code. So then we can implement macros on it. So all these special constructs like if and for can be expressed in simple Perl 6 itself. So you can augment it if you want. And then finally we'll hit bootstrapping. And this is converging toward a certain constant, and which will be a perfect circle. Thank you. And yeah, note that there's exactly 6 milestones, because one more and we'll be hitting the floating point overflow problem in some machines. Okay. Now, having seen what Pux is, let's see what Pux is not. Now, this is a very old joke. But according to Slashdot people, Pux is a frivolous toy interpreter. Of course, what you see on Slashdot must be true. No, not really. And so, as you can see, we're not frivolous. We're pretty serious about finishing those milestones. And having a compiler backend with 3 codegens means we're not only an interpreter anymore. So that leaves toy. And that, however, is true, because Pux as a compiler is not optimizing for speed, it's not optimizing for memory, not yet anyway, and it's optimizing for fun. And fun takes many forms. one of the most interesting thing about pugs is that there's a lot of people working with you. So we've seen nearly a linear growth. Ignore this part, it's a joke. And so as time goes by, we've seen nearly a linear growth of both our committers and the work they do, their commits. And it's not fun if your commit randomly breaks somebody else's code, so we're thoroughly test-driven. From the very first day of pugs, when you report a bug report, I pretend to not hear you unless you report it in the form of a regression test. So, which is why we have 220,000 tests, because all the bug reports are eventually converted into one or more unit tests. And all those tests are run automatically by a cluster of machines and then posted on the web. So when you commit something and it breaks, you know how and when and why exactly it breaks. And we don't stop at implementing the spec. We actually have a lot of to-do tests that are unspec'd, which means Larry and the rest of the people, I guess that includes me now, haven't got around to spec those things, to define those features. So, but we write tests anyway, and then we retroactively add those to the specification. So the interaction between the test and the specification are two-way. So we're also, another fun thing is we're pretty much anarchistic. That is to say, like Wikipedia, if anarchy scares people. And so we have a lot of projects because all our intermediate forms use YAML or JSON or some language-neutral exchange format. So if you want to write, say, an optimizer or a refactoring browser, you don't have to use Perl, you don't have to use Haskell, or you don't have to use C. You can use whatever language you want. And so we have a lot of sub-projects, loosely coupled, and you can join in anytime. And you don't have to wait for somebody's approval to contribute your code to pugs, because we don't believe in patches. This is a very common saying in free software world, which is patches welcome. But if you have actually worked with a free software project of any given size, patches are actually not welcome because it takes a lot of time to integrate to apply a patch. And maybe you submit a patch, after a month, the maintainer finally have time to deal with it. The patch does not apply cleanly anymore, and you waste some time, mail some things, and shout at each other. So patches are not welcome. And instead, we welcome commits. So on IRC, you very often see this. A commit bit is in your inbox now. Don't forget to add your name to the authors file. That means that you can just start committing to our Subversion repository without waiting for anybody to apply your patch. Now, to maintain this style of development, communication is very important. Most of our communication takes place on IRC. That's Freenode Pro 6. We call ourselves Lambda camels, because Lambda people are those functional programming people, and the camels are, of course, CPAN and Perl people. And at any given time, there's maybe 200 people on the channel, and they're fairly addicted. So at any given time in any time zone, there's about 20 people constantly chattering about things not necessarily relevant to Pro 6. And by far the most addicted person is Larry Wall. And he actually considered installing a text-to-speech converter in his living room, so that when he's having dinner or having lunch or something, the IRC can be broadcast into voice band, and so he won't miss the discussions on Pro 6. I think his wife eventually talked him out of it. And in addition to Lambda camels, that's to say humans, we also have robots. And this is a very important robot. This is, I think, the first Pro 6 application that has seen field use. It's also used in some other channels. So this watch is a subversion for commits, and for each commit it announces the revision number, who did it, and the commit log. Now the ++, for those who knows, is this karma system. Whenever you see a ++, somebody tracks, another bot tracks that this person increases her or his karma by 1. So this is our very subtle way to encourage people to write very long commit logs, because each line counts as 1 karma. So people can, they have that motivation to not be lazy. And of course, there's the spec bot, which monitors the specification commits. That is the commits to the Pro 6 spec, the synopsis. So for example, this one from Larry says Q can February, March, by April, May, whatever that means. And, or this one says made this construct a little bit more dwammy, which is do what Audrey means. So things like that. And for people who are in a rush to actually download and install plugs, we have this eval bot. So you can come to our channel, say !eval, some sort of Pro6 code, like this one reduce with plus 1 to 100, and it will evaluate this Pro6 code and display the result. And it's very important for newcomers to instantly get gratification so that one can see Pro6 in action. And the DevBot announces the changes to our track wiki or our ticketing system or some blogs and things like that. And the Lambda bot lets us do somewhat the same thing. We can evaluate Haskell code and ask Lambda bot to refactor our Haskell code into some shorter form or just write the code for us. And in addition to the IRC channel, we also have some websites. This is ircpugsco.org for people who want a searchable log for the IRC. And this one is like try Ruby. If you go here, then you can run Pro6 immediately using Ajax in your browser. This is an interactive pug session, and you can just start running Pro6 in this prompt. And this is our wiki workspace with track. And as soon as you're invited, which is really easy, you just let me or anybody else know your email address, and then you'll be spammed, invited. And so, and when you're invited, you can invite other people here, and so spread the commit bit. And the smoke pugsco.org displays the snapshot versions and on which machines, how many tests are passing and failing. And if you click on the synopsis link, it takes you to cross-referenced specification to see how well those tests correspond to the specification, and which is this one. And there's also the blog, and which chronicles the development and mailing list summaries and things like that. There's also some mailing lists. This is for those very brave early adopters who just gather here and complain that their code are not working. And Pro6 language, where people try to make their code work by changing the language. And this one does not have any traffic at all, because we all work on IRC nowadays. So this is our primary Subversion repository. You can commit here. Here is a read-only darks mirror. But most of us use SVK anyway, which allows us to work offline in a very fast fashion against the Subversion repository, so we don't have to wait for network connectivity. And in addition to those online developments, a lot of development happens in real space, because I was, still am, emulating the lifestyle of Paul Ardouche, who randomly drops by his friend's door and says, you have to provide me with food and shelter and for me to live, but in exchange I'll work with you on some paper you're working on. And after a while, the friend will have to suggest another friend for Ardouche to visit. Otherwise, he'll just stay there indefinitely. So, and I was working more or less like that, staying in different people's place, and locating the key person or people necessary to make that milestone pugs go, and even people in Redmond, and things like that. So currently we're here, and at this July I'll stay with Larry in his place in Mountain View for 1 full month and see whether we can get the standard Perl definition actually formalized. So that was the first talk. The second talk, which is a little bit more interesting, is Pro6 itself, reconciling the irreconcilable, which means there's a lot of things that other languages consider that you have to do either this or that when you're designing a language. But in Pro6, we always choose both sides, even though it's been maybe proven as impossible before. But we do that anyway. And I think it's Dan Kogai who translated into something I don't understand. Reconciling the irreconcilable. So let's first talk a little bit about Perl. P in Perl, as you may be aware, stands for practical, unless it stands for pathetic. And when Perl was first invented back in 1987, when you're programming on Unix, you have to use either C, which is what you'd use for very low-level programming, or shell when you want to do high-level programming, but you cannot do much. It's like this either-or thing that Pro6 always rejects. We always can do both. So when Perl 1 was first being invented, Larry saw that this is not actually a line with two sides. It is actually 2 dimensions. C is very good at manipulexity, which is the ability to manipulate complexity. And shell is very good at whip aptitude, which is the aptitude to whip up something very quickly also known as rapid prototyping. So when Perl was first born, it can do some manipulexity, like C does, but with a lot more ease. You can do something that's very complex that's somewhat quickly, or you can do things a little bit complex very, very quickly. And that's the niche of Perl. That is a very good idea. So a lot of people contribute new ways to do things more quickly or to do more complex things. So Perl 2 starts evolving and evolving and keep evolving into Perl 4. And with CPAN, of course, we have a lot more rooms to evolve until, of course, all your languages are belong to us, which brings us to today, which is now to manipulate complexity, we rely on abstractions. Abstractions are ways for us to express very complex stuff with very simple words. They let us think very higher thoughts without going completely insane, so they're sexy. And Perl 5 already supports closures, which you may have heard Mark Jason Dominus talk about closures and how you can combine functions to make higher level functions so that you can return functions from within a function. As for example, this makes a counter, and calling it increases a counter, and this makes another counter. Then they're very flexible, and you can build very flexible frameworks using closures alone. But even more uniquely, Perl 5 supports the abstraction that we call staged evaluation, which means you can run some code while you're still in compile time by saying begin. So you can negotiate and threaten and maim and hurt your compiler until the compiler compiles your code exactly the way you want it to. In addition, during runtime, you can also generate some string and pass it to eval, which means you delay your compile time until after the runtime. So between begin and eval, you can run your code exactly when you think you have sufficient information to run it. And this is extremely flexible and lets you express very complex concepts like metaprogramming in very, very few words. Perl 5 is also unique among IO languages to support runtime typecasting. If you have this POM object, and you can call POM methods on it, you can, at any given time, bless it to a queen object. And ever after, when you're calling method on it, it actually dispatches to the queen class. And this is very unique among object-oriented languages. But perhaps even more important than abstractions, we also rely on shorthands, which is the whip aptitude part. Because the shorthands feels natural. They maps naturally to the problem at hand. For example, Perl 5 has this idea of contexts. Instead of having to memorize 5 or 6 different function names like they do in PHP, we just say one single function, like this is sender_in. But if it's expecting one thing, then it just reads one line. But if it's expecting many things, then it reads many lines. But of course, this array itself does not really have to have only one single meaning either. If you use it as a string, that is, as part of the string, it expands, interpolates into its elements, rendered as string. And if you use it as a number, that is, you compare it with a number, then it behaves as if it's a number that is the number of elements inside the array. So all this is very, very convenient. You don't have to say, all size or all S string or something like that in order to write your programs. That makes your programs much more concise. We also support type variables. Now, how does this get into here? We also support type variables. So you can pretend that this simple hash is a very simple hash, but if you're accessing it, it actually goes to Google and does a Google search. So this returns the first match and the URL of it, except it doesn't work anymore because Google terminates the SOAP interface. And of course, by far the most interesting shorthand is regular expressions, which has since contaminated every other language. So with regular expressions, you can write very interesting things like DCSS with very short code and with no hope of people understanding it. But all those pales in comparison with the love, that is the community, that is, of course, CPAN. Because the best kind of programming is, of course, no programming. CPAN is a very loose set of clusters of servers, each providing one or more services, that taken together makes someone who wants to reuse or publish a Perl module very, very, how do I say that, seamless? Okay, very seamless. So CPAN has been around for 11 years. There's a lot of developers, a lot of modules on CPAN. But even more importantly, it integrates with a lot of things. It integrates with your package management. It integrates with a rating or ranking system that you can use that to see which module has 5 stars, which module has 3 stars. And when you upload a module that breaks on, say, HPUX under strange circumstances, somebody running the CPAN Smoke service will let you know and work with you to fix the portability bug. And of course, we also have this issue tracking management system. When the maintainer is too busy developing bugs, you can exchange patches among yourselves and report bugs so that other users know that this issue has been discovered. So all this means that it's more important what you can say with Perl than how you say with Perl. That is, the vocabulary is far more important than the syntax when you're using Perl 5 and CPAN. So CPAN is the language and Perl 5 just the syntax. And CPAN, of course, is the best thing that have happened to Perl. But Perl 5 is, well, not the bad thing that happened to CPAN. Because Perl 5 is a biohazard. It hurts my hand, so it's a biohazard because there's a lot of redundancy. You have to type the same thing over and over again, like variables. But so this is not some very strange Perl 5 code. This is everyday CPAN code. You have this method, but we can't say method, so we have to say sub. And there's no way to get the self except for typing this line, which Inky really doesn't like. And yeah, Inky is very into refactoring, so this line is 10% of his programs because all his methods are 10 lines on average. So he said every time he types this, he feels like he's typing myself equals shit. And this is the Perl best practice way of implementing named options, named parameters. You have to pass in hash ref because that's easier to validate. The ref is as a hash and merge it with the default values. And now try to explain that to a newbie. Oh, this is even worse. I take out my attribute, render it as an array, which may actually just fail right here, and call a method on self and call it item. And then I call the same the draw method on it, but passing exactly the same name parameters that has passed to myself with a lot of redundant typing of OPTS here and with a new line. But this is completely idiomatic, good Perl 5 code, but there is a lot of redundancy. So of course in Perl 6 we use a method with default values because we unified the attribute access with method calls. So this is both accessing an attribute as an array and calling a method and expecting it to return an array. And so for each of those things that return by filter, we just say $_, which is hidden here, .draw, and then pass in the same variables here. This is x, and then pipes into $x, y, big arrow, y, z, big arrow, z. So all this is very concise and very convenient. And another bad thing about Perl 5 to CPAN authors is that its internals represents a Jenga Tower, which is some kind of toy that you pull out blocks from a tower until the tower falls. So this is Leon Brocott hacking on Perl 5 internals. He's a pumpkin. And note that he will need a hard liquor to make it go. Otherwise, he goes completely insane. So, and why does the Perl 5 internals represent this Jenga Tower? That was because Perl 5 was committed to bug-to-bug compatibility with not only every single release of Perl 5, but also most releases of Perl 4 and Perl 3 and Perl 2 and Perl 1. So all those bugs that we carefully documented in the camel code, camel book, we cannot actually make them go away because they are now features. So all those shorthands that was invented for the niche when Perl 1 was first released, that's to say text processing or formats or things that people don't use anymore, they take up the mentally allocated shorthand slots, so they are very, very short to write. But then all the newer needs like object orientation or functional programming or parallelizable code or things like that are forced to take longer and longer to write because there are just so many keys on the keyboard. So to maintain bug-for-bug compatibility, it destroys the possibility for Perl 5 to fundamentally change its internal functions. So all the new features must be piled upon old features, and that makes the internals kind of hard to hack on. So all this only means that when you're writing Perl 5 code, there is always a strong temptation to write it in a very short, we say, golf way, and make maintenance very horribly difficult. Or you can write it the best practice way and write it in a very long and carefully documented way, but that takes discipline, and it takes prescriptions like books, like Promedic and Pro Best Practices. You need a lot of books to teach you how to do this. But of course, best practice should be just natural, and that is what Perl 6 is all about. We started in 2000 with a lot of people suggesting ways to improve Perl 5, each in a different direction. And then a lot of people suggested ways to improve the internals instead of the language in a lot of different directions. And now, in 2002, Larry started to look at all those RFCs and see how they fit together or not, and write his design rants as a set of apocalypses, so you can get some feelings of how Perl 6 will shape up to be. In 2003, the internals people tried a way to use access macros to automatically translate Perl 5 internals code into the parrot internals code. That did not really work, so Pony is now late Pony. And in 2004, finally, Larry started to produce a synopsis, which is specifications of how Perl 6 must behave, and without which you can't really implement anything. So after a few months, we have the first implementation. There's, of course, more implementations after that. In 2006, we did a feature component freeze. That is, while the syntax itself may change in the surface, the scope of Perl 6, the fundamental features that it must support, is just that. In December 2006, whatever in the specification will just be there, and there will be no more unexpected chapters that appears. So we call the language at that point V6 Alpha and release a module on CPAN called V6 Alpha, and that you can try to write some Perl 6 code on and expect it to not break too horribly except for syntax changes. And our goal this year is to release V6 STD, which is the Perl 6 grammar defined in Perl 6 for Perl 6 itself you saw earlier. And once this is done, then this is the standard Perl 6. And all implementations, regardless of their runtime system or how they compile or whether they interpret, must honor this standard definition of Perl 6, because that is how Perl 6 should parse and understand itself. That is the semantic meaning of Perl 6. That's the goal of this year. So you've probably seen this before, and Larry first announced the Perl 6, nobody understood it, and then Apocalypse got everyone excited. But after 4 years, nothing runs but Hello World. And at this point, Hello World stopped to run. And people sunk into despair, and then we start gradually to implement it. And last year, we have released a bunch of modules on CPAN, so you can compile Perl 6 to Perl 5. And people hack on those CPAN modules with a lot more energy than people used to hack on both Parrot and Haskell plugs. And so now all those tool sets and our incremental rollout of those CPAN modules and features are just part of the normal course of events in the Perl CPAN community. It is no longer really a big deal. I'm happy that this timeline, which I drew back in 2005, is no longer imaginary. Now, the Perl 6 language itself is about reconciling the irreconcilable. So this is our mascot, which is, of course, everything. Everything that O'Reilly has put on the cover, apparently. So there's a lot of dilemmas when you're designing a language. The things that people, especially professors, say that you must either do this or do that. A language cannot ever do both. And primary among those is the issue of typing, of static typing versus dynamic typing. And both sides agrees that types are good. Nobody really wants to write C anymore. And, but they disagree on whether typing is good. We Perl people and Ruby people and PHP people and Python people and JavaScript people thinks that typing out those types, like int and exception and things like that is really bad. When you're declaring a variable, you shouldn't be forced to think about its type. Especially, you shouldn't think about its type and get it wrong. And the compiler will shout at you saying, this is not the correct type. And then you change it, and the compiler says, no, this is not correct type either. And at some point, you shout back at the compiler saying, if you know everything, then why don't you write out the types for me? I mean, why am I forced to guess those types? So I think most people who are into dynamic typing are really against the act of thinking about types. They would rather either let the compiler or the runtime figure it out for themselves. On the other hand, the static typing people, like C++ people and OCaml people, argue that the static types produce more efficient code. Because if you know that this variable can only hold an integer, you can generate very fast machine code. It is also more robust. If you try to use a, say, cat as an integer, it will not use its pointer address as what will happen in Perl 5 when you use a reference as an integer. On the other hand, the dynamic people argue that not thinking about types makes you more productive. You can write more code in less time. And also, by not restricting yourself to particular types, you can use duck typing, which means when you need an unexpected news of an existing library, you don't have to go in and modify the library's types. You can just call the methods and pretend that it just happens to have them methods of the same name. So of course, Perl 6 takes both sides. We implement gradual typing with type annotations and type inference. What this means is that you don't have to write types, but if you do write types, we make your life better. So this is Perl 5. It calculates the distance between 2 points given the distance on the x and y axis. So F34 returns 5 because it's calculated this way. And when this is ported to Perl 6, the only thing changes is the sigil. Nothing else changes. This continues to run. You don't really have to declare 5 as some type or the subroutine foo as taking some type, returning some type. All this still just work. On the other hand, if you say sub f takes 2 arguments with names with types, and the variable also carries a type, then it makes sure that nothing that is incompatible with num will ever go into 5. And if something goes into it, it reports it as an error either during compile time or runtime. It can also possibly generate more efficient code. But it does not actually stop here. You can define a subset type of number where it has to be larger than 0 and call it positive. And this is like a constraint on an existing type. So you can say that the subroutine f actually only works on positive numbers because calculating the distance between negative distances does not actually make sense. So it takes 2 positive numbers with an additional constraint on its return value, which is not only positive, but it has to be larger than both of its incoming values. So this is like assertions written in a very compact fashion that the compiler will honor for you. But the body, of course, is still the same. So when you bind this result, instead of assigning it to $5, binding means you can't actually assign a different value later. So the compiler has sufficient information to know that this has to return a positive value. So this is allocated as storage of positive, that is num, and you don't actually have to say my positive $5. And that is what type inference means. Another dilemma in language design is between domain-specific languages and general-purpose languages. Domain-specific languages like SQL and regex are embedded inside other host languages most of the time, but they have different grammar, different routines, different conventions, different execution models. But because of this, because they're domain-specific, they're very concise. What 80 characters of regex can do, you may take 80 lines or 80 pages to do in other languages, especially XSLT. And when you're doing domain-specific languages, you can also be very expressive because they have a lot of shorthands tailored to that domain. On the other hand, general-purpose languages, the most general of which are Lisp and C, have benefit too because they're versatile. The same library designed to solve one problem, you don't have to invent another language to solve another problem. You can reuse this library when you're solving a problem in a different domain. So any library expressed in a general purpose language could be potentially used when you're solving things in another domain. So they each have their benefits. Now, Perl 6, of course, is both a domain-specific language and a general purpose language, because our compilation flow is extensible, because we have macros. And what macros means is that at compile time, in addition to like in the Perl 5 begin block, you can run some Perl code, you can actually change how the compiler works. And instead of just pragmas like strict and warnings, you can swap out parts of the compiler into other parts written in Perl 6. So you can swap out the lexer, which is the part that recognizes the characters in your program. So after installing a macro in the circumfix category of this, taking anything parsed into nothing, you can just start writing C-style comments, because after this line, Perl 6 will start parsing this as a macro call to this macro, which returns an empty string, which is filtered, of course, into nothing. And you can also install operators in arbitrary categories like postfix. So if you want to implement this exclamation mark operator, which takes a number like 10 and replace 1, 2, 3 to 10 to 1 times 2 times 3 times 10, then you can just say that, and then it will calculate the value correctly. And in addition of normal macros that only captures the variables in their scope, you can also quasi-quote, that is to use some sort of Perl 6 program snippet and represent it as an object. And you can use this directive to say, I don't know about $S right now, but whatever $S is in scope when you're calling the greetings macro, I'll use it. Of course, it's very dangerous, but it's also very powerful. So by saying greeting here, it would just say hello world. Another, not really dilemma, but two different schools of language design is between lazy evaluation and eager evaluation. Lazy evaluation is like Haskell and, well, Unix pipes. When you're saying, catch something or do something pipe to less, less does not really wait for the previous process to complete. As soon as there's some lines available, less will start displaying it on your screen. And that's what lazy evaluation means. It means that when you're calling a function and passing it with some other function call as its argument, it does not actually have to wait for the inner function call to complete. What this means is that it's very modular, because you're not forced to write your producer part and consumer parts in the same program. You can read a very large file and pretend it's slurped into memory, but it's actually not. And it's only read when you're actually making use of the lines. It's also very reasonable, because then your producer parts and your consumer parts can be reasoned in a mathematically sound fashion. When you're refactoring, you don't have to worry about global variables and package variables when you're writing your code in a way that utilizes lazy evaluation. Of course, everybody else uses eager evaluation, which is very direct and which is very predictable. Now, Perl 6, of course, does both, because you can annotate your expressions to show whether it's lazy or not. And the default laziness is based on the context. Because, as we know, there are two primary contexts in Perl. There's scalar context, that is when you only want one thing, and list context when you want many things. In Perl 6, whenever you want many things, by default, those many things are calculated lazily. So in Perl 5, you would say while diamond print $_, something like that. But in Perl 6, you don't have to use a while loop anymore, because when you say a for loop, this pretends it reads everything from the standard input or the argument, but it actually only goes back to read it when this is actually run. So this is the Unix cat. It tries to read a line and print it, read a line and print it, and things like that. A little bit more interesting is when you want to annotate each line with line numbers. For example, the first line, I wanted to say line 1, colon, the first line, line 2, colon, the second line. And when you're doing this, it's very simple. You just say each, and then join two streams together. The first one is from 1 count to infinity, and this reads whatever. From 1 counts to whatever. And this is the original lines. And in the for block, you just print line and $correct number, which means this block takes this as a parameter, and it reads from the 1 here, and this reads from the line here, so you print line 1 with this line number. And then it goes back to read the second line and print line 2, because num is now the second element, which is 2. Now, why does it know that num reads from here and text reads from there? That is, why is the num the first parameter and text the second parameter? That was because num sorts before text. Because alphabetically, n comes before t. That's very sick, but it's true. So while lists are lazy by default, we can use bindings to define a list lazily with itself. Note how we can refer to @fib before this semicolon terminates. Perl 5 does not let you refer to a variable you're declaring with my until the next statement, and Perl 6 does not have this problem. So you can define the Fibonacci sequence as something beginning as 0 and then 1, and then taking itself, and then taking itself again, but skipping the zeros element that is counting from the second element onwards. Zip them together, and then feed them into a map that takes the infix plus, which takes 2 arguments at a time. So what it does is the fib will start with 0 and then 1. And the next element will be 0 here and 1 here, plus together into 1, and then 1 here into 2, 3, 5, 8. So it's an infinite list defined in terms of itself. So when you want to print out these first 10 numbers, you just say the first 10 numbers are fib. And this is another shorthand that means 0.9. So those are the first 10 numbers. And in scalar context, things are eager, which means it's evaluated as soon as it's needed. But if you say lazy here, then it becomes lazy. So this is a very large number. It's a Google, and this is a operation that prints out a lot of things to your terminal. But if your main program does not use those variables, they're unused, and so they're ignored. They're lazily evaluated. And if you want to use lazy in Perl 5, there's a perfectly good and sane implementation of it on CPAN. You just download the scalar defer module and play with it. And another dilemma is between class-based languages, which has a lot of types to type, and very disciplined. And there's also other OO model languages using prototypes, which is very adaptive. You can change things without understanding it, and it's also very convenient. So Perl 6 has this meta-object model that lets you use many different object models to write your programs. So this is a normal class. It inherits from mammal. It implements an interface, a role, and it has a class-wide accessor into a property. So maybe there can only be at most 100 dogs. An instance can have private attributes, public attributes with default values, public attribute that could be assigned to, public attributes that handles anything that's defined in this role. And when you call wag or hang, it delegates to this attribute. And when you call, this is very good for backward compatibility of APIs. When you call it with any method that begins with owner underscore, it redelegates it into the rest of the name and calls it to the result value of the companion method. So when you're creating a new dog object, you can use how to get back the class object, or you can use what to get back the prototype, which in Perl 5 is the dog string, which can behave as a class. You can also get the ID and inquire whether it inherits from dog. It is an instance of dog. And then with this meta class, you can add a new method very programmatically using an anonymous method so that all dogs can additionally bark, and Fido, the instance, can, of course, also bark. And another dilemma, and I'll finish this very quickly, is between threads and processes. Because the CPUs are only getting a lot more instead of getting any faster. So there are people who advocate threads, which are very intuitive ways to share variables among different CPUs, so you can parallelize it. But then managing those shared variables is a lot of pain. Or you can use processes, which is very deterministic. It's easy to manage, but it's very hard to make it scale well. Concurrency is a good thing. But to lock things, to implement concurrency, just kills people. So a very common problem with concurrency is that you want to run this in a thread, but then in between, some other thread access those two variables, and then discover that there's money missing because you withdraw from X, but did not yet deposit to Y in the other process. The classic solution to this in Perl 5 and other languages, you lock it before you access it. So other threads, when they're trying to access those things, will block until this block finishes. But then if the other thread acquired the lock in a different order, then, well, this will just cause a deadlock. Because this thread will wait on X, and this will wait on Y, and nobody gets anything done. So in Perl 6, we implement transactions in our default variables. So a asynchronous thread can say content, which is like begin transaction in database. Whatever you do will not affect other threads. Other threads will always see X and Y in the previous state, but they can continue running on. And by the end of the brace, it will commit both of the values simultaneously, so other threads always see a consistent value. There's no need to lock anything, and it's either both are committed or both are rolled back, again, just like databases. So with this, you can implement a lot of interesting features like defer, which checks whether this object has sufficient balance. If it does not, then instead of just doing a busy wait, it rolls back to the transaction and wait for other thread to write to this attribute for it to continue. And you can compose multiple such things together with maybe. So if $x1 does not have sufficient amount, it delegates to $x2 before it retries. And you can nest those maybes together very easily. Now finally, the last thing next to last thing is parallelism. That is, for APL and Fortran, it can take a very big array and say for each element in the array, we add it by 1, or we calculate square root. They call it vector programming. And it's very, very simple, and it's very scalable. A lot of GPU graphic processing using this sort of processing, or people in Google use MapReduce, which is another way of doing SIMD. And everybody else use concurrency that involves different processor threads that has access to a lot of different types like trees and hash tables in addition to arrays, and with a very familiar flow. But then they're not as fast or as scalable as vector processing. So in Perl 6, whenever you use those hyperoperators, you promise to the compiler that you do not care about the order, how those numbers are added together, because it really doesn't matter. Whether you add the 1 first or 3 first, it doesn't matter. So currently in PUCs, this makes use of additional CPUs or SSE instructions or GPUs if you have one available. And so it can add all those numbers in the same time. And in addition to mere arrays, you can also recursively count the negation of every element in a complex tree, or count the square root of a big list. Again, this means you don't care about the order they are evaluated. So this MacBook has 2 CPUs. Calculating this takes 9 seconds. But when I tell PUCs that I can use both of my CPUs, it reduces the time by nearly half. If I have more CPUs, of course, it becomes linearly faster. I don't have time to cover junctions, so let's pretend. Okay, the final dilemma, of course, is my language versus your language. Perl 6, of course, the advantage is that it's better and better. Of course, other languages are also better in different ways. So what Perl 6 does, of course, is be the language that can use arbitrary other languages modules. This is not a new idea. This is just an inline idea. So it can use whatever language they recognize and the favorite module in that language they want. It's Babel 11, Babel 17. So this actually runs today in PUCs. A few weeks ago, actually, you can use Java-Lang system, and then call arbitrary stuff in the Java. Of course, you have to set a class path correct. But otherwise, it just works. I needed this for my day job, so I implemented it. It's really simple to use. So by targeting multiple virtual machines and by embedding other languages runtimes into PUCs, you can use whatever language's favorite module of yours and not worry about its compatibility with Pro 6. So by this time, everybody's asking, when will Pro 6 finally be released? Of course, everybody knows the answer is by Christmas. We never say which Christmas, although we're working very hard for it to be this Christmas. And, but also, it will be Christmas because when Pro 6 released, every day will be like Christmas. Now, I think my translator added this. I didn't have this before. Okay. So that it is. Thank you very much. So sorry about going massively over time. I'm not sure whether we have time for questions.
まだ1つか2つぐらいしかちょっと時間があれなんですけど、質問とかある方いたらお願いします。Questions? Maybe they're too tired for the day.
So that's what you get when you're the last talk in the conference. But thank you very much.